Okay, next we're going to look at the actual configuration of an IPsec VPN tunnel. We're going to use the CryptoMap configuration we're going to do an IPsec VPN tunnel between an ASA device firewall and the iOS router. So we're going to fire up a VPN tunnel IPsec with IKv1 between ASA3 and router 1 with a scope of, let's say, securing traffic between VLAN 47 and VLAN 94. So we're going to want the router ASA3 and router 1 to build those two unidirectional IPsec tunnels with a scope of protecting traffic between VLAN 94 and VLAN 47. Now we're going to use both the GUI of ASDM on the ASA and the CLI part. So as I said before, there are multiple configuration options to build an IPsec VPN tunnel, but for the CCNA security exam, CryptoMap is in the scope of that. We're going to use CryptoMap. We're going to make use of pre-secured authentication to authenticate the VPN peers, and we're going to make use of IKE or IKv1 as the key management framework. Now, at CryptoMap configuration, the IPsec tunnel is built on demand. With other IPsec VPN tunnel, with other configuration options, the IPsec tunnel is self-triggered, but at CryptoMap is going to be built on demand only as the VPN gateways are going to detect that they have to send traffic to the IPsec tunnel, and at that point, they're going to fire up the negotiation of the IPsec tunnel to begin with. And of course, on both ASA and iOS, you have to configure phase 1 and phase 2 parameters, and then of course send traffic to the IPsec tunnel. Phase 1 configuration on ASA and iOS, we're going to have to configure matching ISAC and policy attributes. On the iOS, we're going to have to configure the pre-share key globally. So phase 1 means configure the ISAC and policies to match between the VPN gateways, and if you use pre-share key authentication, it means both gateways have to be configured with the same pre-share key. And on the iOS, we're going to do that globally. On the ASA, how the pre-share key is configured is different. First of all, we have to enable IKE or ISAC on the VPN terminating interface. On the iOS is enabled by default. On the ASA is not enabled by default. That's a difference between the ASA firewall and the iOS device. Makes sense because the ASA firewall is a security device, so you would want to have control over everything you do on the firewall, while the iOS router is not a security device, so it has IKE enabled by default. So additionally, on ASA, we have to enable IKE on the VPN terminating interface, and we have to configure a tunnel group or connection profile of type LAN to LAN, and under that tunnel group we're going to configure the pre-share key. Phase 2, on both ASA and iOS, you got to configure the proxy ACL, the transform set, a static CryptoMap, and then apply the CryptoMap on the VPN terminating interface. So the proxy ACL defines the encryption domain, the transform set, the encapsulating protocol, the mode, and encryption and hashing options. And then the scope of the CryptoMap, which is nothing else but like a route map, is to, because the proxy ACL being globally configured like an access list, and the transform set being globally configured, they are useless unless you combine them in one common container. That's going to be the CryptoMap, which is nothing else but like a route map, but with a different scope in order to provide security to IP traffic. So it's a map used for crypto protocols. In a CryptoMap, we're gonna bind in there the proxy ACL, the transform set, and we're gonna configure the remote VPN peer IP address. So it makes sense because under the CryptoMap, we're going to say, dear router, so dear ASA firewall, if you see traffic matching the proxy ACL, which is in the CryptoMap, then I would want you to secure the traffic as the transform set states, and this is your VPN peer with whom I want you to negotiate the IPsec tunnel. So configuration makes a lot of sense. Verification-wise, phase 1 on the iOS, we verify if phase 1 was built with SureCrypto ISAC AMP-SA or SureCrypto ISAC AMP-SA detail. If phase 2 was built with SureCrypto IPsec SA or SureCrypto IPsec SA detail or SureCrypto map. and we can verify both phase 1 and phase 2 with one single command, show crypto session detail. And again, the commands, as I said throughout the whole class, the commands make a lot of sense. So like, because phase 1 builds a IPsec, which is the ISACamp assay, it means that the command makes sense. Show me the crypto status of the ISACamp assay. While because in phase 2 actually negotiate what is the scope of the IPsec tunnel, because what we negotiate in phase 2 is going to end up what we can send in the IPsec tunnel, it makes sense the command is going to be show me the crypto status of the IPsec assay. While for phase 1 and phase 2, if you want to verify both of them at the same time, the command is going to be show me the crypto session details. So crypto session would mean I don't care about phase 1 or phase 2, just show me the session status, which means for a VPN tunnel to be built with IPsec, it means that both phase 1 and phase 2 have to be up. So that's why the command is show crypto session. Show me the session details of all IPsec VPNs being built. On the assay, it's pretty much the same, but just a bit different because it's a different platform. You verify phase 1 with show crypto IKv1 assay or IKv1 assay detail. It's the old command show crypto ISACamp assay still works, but it's hidden in the new codes. So ideally, you should use the new command, and it makes sense because I'm using actually IKv1 to be not ISACamp. So it makes sense the command is show me the crypto status of the IKv1 assay. So if phase 1 is built or not. Phase 2 is the same, show me the crypto status of the IPsec assay with or without detail. And if you want to verify both phases, the assay has another command, show me the VPN session database in detail to see the details of type LAN to LAN. So that command is like the show crypto session detail, but it's a different format because it's a different platform. They just brought up a new command. And of course, on the assay, you can also verify that from the SDM by looking in the monitoring tab. So now let's go and configure that VPN tunnel between AS83 and router 1. What I'm going to be doing, I'm going to go on test server A and manage the ASA, and we're going to run a wizard in there. Let's say refresh. Let's actually connect again to make sure this session is not stale, because we may end up configuring something which is never going to get applied. Let's kill the process and open it up again. So the VPN tunnel is going to be built between AS83 and router 1, which means it's going to be built between the IP address of the ASA on this interface. It's going to be 136.1.37.16, and router 1's IP address on this interface, which is going to be 136.1.13.1. Let's see if we can. Well, of course, the problem is, let's remove. We had zone-based policy firewall. That's a problem on router 3, and we from the previous example, and we haven't allowed HTTP traffic in this direction. Let's go on router 3 and disable zone-based policy firewall. So on router 3, I'm gonna say show policy firewall config zones, and I'm gonna go on the interfaces and remove them from detach them from the zones, which means at this point zone-based policy firewall is configured but not active, because interfaces are no longer a member of any zones. And on this interface is going to be no zone member security trusted. Let's go again on the server A, and now ASDM should work, and there we go. So we go to the wizards tab, up here, and we say VPN wizards and site-to-site VPN wizard. So we say next. Then the first tab, we have to configure what is the remote peer VPN address. What is the remote peer, my peer's VPN IP address, which is going to be router 1's IP address, and on which what is the interface terminating the VPN tunnel. In my case, it's going to be I'm going to terminate the VPN tunnel clearly on the inside interface in here. And the peer, the ASA's VPN peer is going to be router 1, which is 136.1.13.1. So 136.1.13.1. And I'm going to terminate that on the inside interface. Say next. Then we define a proxy ACL. It says in here, traffic to protect. So what do you want to protect through the IPsec tunnel? And we want to protect traffic between VLAN 47 and VLAN 94. So source is going to be, because this is from the ASA's point of view, which means from the ASA's point of view, traffic is going to flow this way to the IPsec tunnel. Source is going to be in the ACL VLAN 47, and destination is going to be VLAN 94. So local network is going to be the internet network, and remote is going to be 172.16.10.0/24. Now security means we can put in here what I call simple configuration, which means we just configure the pre-share key. So simple configuration means use pre-share key authentication. Well, customize means you have the options to configure back and forth advanced options, like even including the IPsec policies specifically, and also PKI authentication. So if we say customize configuration, we're going to enable it just for IPv1. Authentication methods, pre-share key is going to be, let's say, CryptoMap IPsec VPN. Let's make sure CMap IPsec VPN. Now I forgot to state something which is very important. The pre-share key is not going to be the encryption key. I hope that it's obvious. Pre-share key is going to be used, if you look in RFC 2409, as a seed value to derive the keying material in order to authenticate the VPN gateways and derive the encryption keys, the integrity keys, but it's not going to be the encryption key clearly. Encryption algorithms, that's going to be for phase 2. IPsec policy is global. Okay, so the IPsec policy is going to be, let's say, AS128 SHA and pre-share. Okay, well actually it is built in. Unfortunately, we're gonna see that the wizard is gonna enable a lot of IPsec policies, which that's of course that may not be what you want. So in here you have the encryption, encryption and hashing and everything for phase 1. That's the IPsec policy, and then the IPsec proposal is a transform set, which is gonna be the encryption, hashing, ESP or H, so encapsulation method for phase 2. Let's leave it as it is to with all of those options. Let's say next for the moment. And we don't want PFS. By default it's being disabled. We don't have that enabled. Let's say next. And if we say finish, let's actually copy paste this in Notepad. Because clearly this is not something that you would want to do to end up with all of those configurations in there. And I'm not sure, let me say back if we can from ASDM, if we can change in here not to use all of those encryption protocols. Encryption algorithms. If we say select, let's select only one. We want to use ESP AES, let's say 256 with SHA in tunnel mode design. And for phase 1, fortunately the GUI is going to enable all of those policies. Let's say I'm going to use, let's say delete in here. I'm going to use AES 128 with pre-share and delete the other ones. Priority 1 pre-share, let's say, let's use triple this for phase 1 just to make it different. Group 2 and MD5, for example, for phase 1. That's the IPsec policy. Lifetime leave it the default to 1 day, 86,400 seconds. Okay, and okay. And next. Next. Finish. Actually, we see this, it still has enabled all of those transform set, which it shouldn't. Let's say back to look again. Let's start the wizard again, yes, because probably it kept something in memory. Let's say wizard, VPN wizards, side-to-side VPN wizard. Next. So peer adders 136.1.13.1. VPN is going to be terminated at IPsec tunnel on the inside interface. Local network 136.1.47.0 remote 172.16.10.0/24. There's a typo in there on the network. I forgot a slash. Let's say customized. Only IKv1. Authentication method. Pre-share key. Well, let's say just a basic key Cisco. Keep it simple. Encryption algorithms. For phase 1. Let's delete all of them. And we want to bring our own phase 1 policy. Priority number doesn't need to match between peers. Is local significant. Authentication pre-share. Encryption, as I said, triple this. Defilement group 2 and hashing, let's say MD5, just to be different from phase 2. Okay. And then IPsec proposals, likewise, let's delete all of them. And add only the one with AES 256 SHA-1. And say assign. And okay. Let's say next. Finish, and let's see if now it looks better. Actually, it doesn't. It's going to put all of those transform sets in there. So that's not something that we would want in general. So let's still copy the configuration in Notepad. So I see it up here. And let's open up Notepad. And let's edit that config, also look at it to see those two phases clearly. Let me quickly reorder this, and then, because this is not likewise not actually needed. Let me edit this, and then we're going to look at it. I used the GUI just to, of course, show the GUI, but probably it was way faster for me just to write the commands instead of editing what the GUI has pushed in there. Hash auth pre-share group 2 and encryption, I said triple this. That's phase 1, and also phase 1 is going to be the pre-share key, which means the tunnel group. So phase 1 means enable IPsec or IKv1 on the VPN terminating interface, configure the IPsec policy, and then configure the pre-shared key for that VPN tunnel because I'm using pre-shared key authentication, and that's being done under a tunnel group of type LAN to LAN, IPsec LAN to LAN. And I'm going to put in here the IP address of the remote VPN peer, which is router 1. Then we're going to move to phase 2, which means the proxy ACL. What do you want to encrypt? Let's give it another name. Access list, let's say IPsec between ASA3 and router 1. And the content is correct. So this is phase 2. Now what to encrypt, not how to encrypt, how to protect the transform set. And we said I'm going to use AES-256 with SHA-1, which should be this one in mode tunnel. So crypto IPsec IV1 transform set, give it a name. Let's say T set for IPsec between ASA3 and router 1. And the other ones, I don't need the other ones. So you need a single transform set. If you configure multiple of them, they're going to be negotiated. But of course, it doesn't make sense to put all of those options in there to be negotiated. Better off just put a single transform set, and of course, which needs to match between the VPN peers. So encryption domain, what to protect, transform set, how to protect, using ESP as a encapsulation protocol, AES-256 for encryption, and SHA-1 for hashing, and of course it's going to be mode tunnel by default. And then combine together the access list and the transform set and the static crypto map, which of course we're going to give it a better name. Likewise, it's going to be crypto map, let's say inside is good enough, because it's going to be the crypto map applied on the inside interface, because we can apply a single crypto map on an interface, not more of them. So crypto map inside match address this. So we bind together the proxy ACL in the crypto map, then the peer, and then the transform set, and then we apply the crypto map on the VPN terminating interface. Let's paste this on ASA3. Let's paste phase 1 to begin with. And now let's paste phase 2 configuration. Crypto map inside and of course probably I forgot to put the sequence number. Crypto map inside a sequence number of 10 and 10 and 10. Let's paste it now. Which now this should be correct. Show run crypto map. Okay, that was the configuration on router on ASA3. So that was phase 1 per what I've discussed before in the presentation, and that is phase 2. Next we go on router 1. We follow the same steps, crypto ISACAM policy, 100, authentication pre-share, so everything has to match, hashing MD5, group 2, encryption triple des, and that's it. And also the key crypto ISACAM key Cisco for the ASA, because I'm gonna use this pre-share key to negotiate an IPsec tunnel with who? With ASA3 136.1.37.16, because that's the ASA's address on this interface. Let's confirm that. ASA3 show name if, not show name if, show IP address. It is 37.16. That was phase 1. And now phase 2, the access list, IP access extended, IPsec between ASA3 and router 1. And from router 1's point of view, the source is going to be VLAN 94, destination VLAN 47, because this is what router 1 is going to encrypt. Traffic from VLAN 94 to VLAN 47. So permit IP from 172.16.10.0/24 to 136.1.47.0/24. That's a proxy ACL. The transform set, crypto IPsec transform set, give it a name, T set for the VPN between ASHV and router 1 is going to be ESP AES 256 and ESP SHA HMAC to match the configuration of ASHV. And then we combine the transform set and the proxy ACL in the crypto map. Crypto map, give it a name of VPN, and we say we give it a sequence number likewise, and it's called, it's of type IPsec ISACAMP, because this is going to be used to bring up an IPsec tunnel using ISACAMP or RIKE as the negotiation protocol. And we say if traffic matches that ACL, match address, just like in a route map condition, match something, match address that ACL, then I want you to bring up a tunnel to negotiate a tunnel with ASA, set peer 136.1.37.16, and I want you to secure the traffic or transform the traffic as configured in this transform set. And just like on the ASA, the last step is to apply the crypto map on the physical interface where the VPN tunnel is going to be terminated, gig 00. So interface gig 00, crypto map, VPN. So on the router, the configuration is going to be show run section crypto. Configuration for phase 1, the ISACAMP policy and a pre-shared key for the remote VPN peer. Then for phase 2, we have, of course, also the access list section crypto and IP access list. Then for phase 2, we have the proxy ACL defining the encryption domain. So what to protect to the tunnel, how to protect the transform set, and then we bind those together in a crypto map, static crypto map of type IPsec ISACAMP. Again, because the crypto map is going to be used to bring up an IPsec tunnel using ISACAMP as the key management protocol. And I'm telling the router, if you see traffic, if you have to route traffic matching that ACL, then don't route it in clear text, but bring up an IPsec VPN tunnel with that peer. And if the IPsec tunnel comes up, then I want you to secure the traffic as that transform set states in there. Now at this point, show crypto ISACAMP SA, as I said, because the tunnel is being built on demand, there is nothing, no state in there. Likewise on ASHV, show crypto IV1 SA, nothing in there. If we go on ASHV and we say also show crypto IPsec SA, you see nothing on the SA. However, if we go on the router, because it's a different platform, the router has a state for phase 2, but the tunnel is not up. So now to fire up the tunnel negotiation, we have to initiate traffic between VLAN 94 and VLAN 47. So let's go on test server A and ping router 4. As we're going to see, the first packet should fail because when router 1 receives a packet destined to VLAN 47, it's going to drop the first packets, it's not going to buffer them till it brings up those two unidirectional IPsec tunnels. So the first packets are being dropped because the router says this traffic has to be secured. So let me bring up the tunnel, and then when the tunnel comes up, the following packets are going to be sent securely back and forward to the IPsec tunnel. So it's expected that the very first few packets are going to fail because the router and the DSA now need to negotiate the tunnel. They cannot route that traffic in clear text. Let's go on server A and ping router 4. Let's confirm that ASA refresh. So let's go and say ping 10.4.4.4. Show crypto IPsec MPSA. Well, traffic didn't work. Let's confirm that Router 1 has that crypto map applied on the gig interface. And it does. Because I pinged the loopback router for not that destination, right? So that's a confirmation that tunnel didn't come up because the traffic I sent from server A didn't match the proxy ACL because I pinged with a source of the subnet, but destination was not that subnet, it was 10.4.4.4. So let's actually ping something in that subnet. So the first packet fail is expected and then it works, which means probably because the IPsec tunnel is being up. So let's go on Router 1 and say show crypto IPsec MPSA. And if phase 1 is up, you should see in there QM idle in there or active, but it can also be standby. So in general, you're going to see in there QM idle and active if the tunnel is up, but you can also see QM idle and standby. If you say detail, you're going to use this to ensure that they have negotiated the proper parameters as you configured in the IPsec policy, which is a confirmation the gateways have negotiated triple-less MD5, pre-secure authentication, and Diffie Hellman Group 2. Likewise on ASA3, show crypto IPv1 SA, detail. We see in there that I have a tunnel output Router 1. State is main mode active because I used main mode for phase 1. And we negotiated clearly the same triple-less MD5 pre-share key. And if we look on then phase 2, show crypto IPsec SA, we have 3 encrypted packets, that was the echo requests, and 3 decrypted, the echo replies. And we see the proxy ACL is configured. And we now have one inbound SA which is active. That's one IPsec tunnel, and one outbound SA which is active, because those are 2 individual SAs. And we have negotiated to secure the traffic as configured in the transform set, ESP, AES 256 and SHA-1, and I'm running in tunnel mode. And the SA is active, both inbound and outbound SAs are active. And of course this confirms that traffic worked through the IPsec tunnel. If we ping some more from server A now, like 5 more packets, or how many packets were there? 1, 2, 3, 4 of them. It means I should see in here now 7 packets being sent and received through the IPsec tunnel. And there we go. Likewise, if you go on ASA3, show crypto IPsec SA, we should see pretty much the same thing. So the proxy ACL as configured, 7 packets being sent back and forth to the tunnel, 7 echo requests, so encrypted one way, decrypted the other way around. Of course, the tunnel is up with on the local address of the SA, and the peer is router 1, remote crypto endpoint. And we have one inbound SA which is active, and we negotiate as expected what was configured in the transform set, and it's a type LAN to LAN in mode tunnel, and IPv1 is used as the key management framework. So the output is a bit different between the ASA and the iOS. And then we have one outbound SA which is likewise active, and of course the same transform set and the same mode of tunnel with IPv1 as the key management protocol in there. And show crypto session detail is going to be the verification of both phase 1 and phase 2. We see that we have with ASA the session is up, which means phase 1 and phase 2 are up. With who? With ASA3. And this is the IKE SA, which is active, the IKE tunnel. And these are the 2 IPsec SAs. So this is the proxy ACL, which says the IPsec is going to protect what traffic flow between those two subnets is configured. Then we have two active essays because it's each one in each direction from the cryptomap configuration, and 7 packets being sent back and forth to the IPsec tunnel. On ASH3, show VPN session database, detail of type LAN to LAN. We see in here the ICSA, which is active, and we see what we have negotiated: pre-secure authentication, MD5 hashing, triple disencryption. We run on main mode, and if you hit group 2, and we have the IPsec tunnel, which is likewise up, and then the proxy ACL is configured, encryption and hashing is configured, encapsulation mode tunnel, and packets being sent to the IPsec tunnel. Okay, next we're going to go to the SSL VPNs. Actually, before one more thing, let's look also in the SDM GUI in the monitoring tab. So let's say cancel and refresh in here on the SA refresh. I want to quit the wizard, refresh, and we go to the monitoring tab and then to the VPN section because I want to see the status of a VPN tunnel. And we look in that sessions VPN statistics, in the session statistics, and we have in here the connection profile, and in here in this box we see that we have how many VPNs up? 1, and it's of type IV1 IPsec. If we look in here and it say details, this is going to show you the same output from the show VPN session database detail LAN to LAN. This is the output of the status of the ICSA, which is up. So IV1 SA, and then further down the status of the IPsec SA. So it's the same output from the show VPN session database LAN to LAN detail, but of course in the GUI format.